All right, welcome back to another episode of Science with Surbeck. Today, what we're going to be talking about is section 11.2, which deals with mass and the mole. So before we get into details of the notes, I just want to outline a couple of objectives. Objective number 1, relate the mass of an atom to the mass of a mole of atoms. Objective number 2, calculate the number of moles in a given mass of an element and the mass of a given number of moles of an element. Objective number 3, calculate the number of moles of an element when the given number of atoms of the element is given. And objective number 4 is to calculate the number of atoms of an element when given the number of moles of the element. So let's get started with what we call molar mass. Now, molar mass is defined as the mass in grams of 1 mole of any pure substance. Now, before we can really get into the details of molar mass, we need to do a little bit of review of the chemical mole. Remember, the mole is defined as the number of representative particles or carbon-12 atoms in exactly 12 grams of pure carbon-12, and that is a carbon-12 isotope. Now, some things to take away out of this is the following. Number 1, the mass of 1 mole of carbon-12, or the isotope carbon-12, has exactly 12 grams. Now, the molar mass of all other elements is established relative to the mass of 1 mole of this carbon-12 isotope. So again, this business about carbon-12 or the isotope carbon-12 just establishes a quantitative or numerical value that we can associate grams with for a mole of a particular substance, or even in this case, an element. So what we have to remember is this, and this is our next key point here, is that the molar mass of any element is numerically equivalent to its atomic mass and has the unit of grams per mole. Now, the atomic mass of every element can be found on the periodic table. So if we piece all of these last two things together, we can have this. If I have the periodic table, and down below, let's say boron here. Boron has the atomic mass of 10.811, or the average atomic mass. Well, I can say that in 1 mole of boron, that there is 10.811 grams for every 1 mole. So not only is this the atomic mass, or the average atomic mass found on the periodic table, but it's also the number of grams in 1 mole of each element on the periodic table. So it's just another use that periodic table serves. And what we can do with this business of molar mass is we can tie it back to what we have already talked about, and that is Avogadros number. Okay, so with Avogadros number and the molar mass, the way we tie it together is by this statement here. For each mole of a substance, there exist 6.02 times 10 to the 23rd representative particles, which means or stands for atoms, molecules, or formula units of that particular substance. So to help us understand this, let's go through some examples. Our first example is this. In 1 mole of copper atoms, there is exactly 6.02 times 10 to the 23rd atoms of copper. And in 1 mole of table sugar, which has the formula C12H22O11, there is exactly 6.02 times 10 to the 23rd molecules of sugar. And in 1 mole of magnesium sulfate, which is just Epsom salt, it contains exactly 6.02 times 10 to the 23rd formula units of Epsom salt. Now, it's important to remember this. Yes, all of these things that say 1 mole equals 6.02 times 10 to the 23rd representative particles. But the masses of each substance is going to vary. So, for example, 1 mole of copper atoms equals 63.55 grams. And 1 mole of table sugar equals 342.30 grams. And then 1 mole of magnesium sulfate equals 120.38 grams. So you can see what the role or what the impact of Avogadros number is on our molar mass. And we're going to utilize that knowledge that we know about Avogadros number, and we're going to use it as some final calculations here. So what we're going to do is we're going to move on to a few examples. And this first example that we're going to move on to is converting moles of some substance to mass. And so what I'm going to do is I'm going to outline the steps for this process. So the first step of this process is to write down the given number of moles of whatever element is given. And I should mention this, that this is only for mole to mass conversions of a single element. Now, the second step in this whole process is to determine the molar mass of the element. And this is also known as the atomic mass of that element. Now, the atomic mass can be found on the periodic table. And then once you've found the number of grams per 1 mole of that element, you just need to set up the conversion factor. Now, after you've set up the conversion factor, you need to calculate and show the correct unit. And in this case, it's going to be grams of whatever element you are given. All right, so let's go ahead and try these steps out on our example below. So we want to calculate the mass in grams of 0.045 moles of chromium. So the first thing, the easiest thing that we can do is we can write down what is given. Now we are given 0.045 moles, so 0.0450 moles of chromium. Now, in case you forgot, chromium, we can look it up on the periodic table, and chromium has the symbol of Cr. So right there, there's chromium. It has the symbol of Cr. So that's what we're going to put there. And then we're going to set up that initial conversion factor. Now, in this particular setup, we now need to figure out, well, how many grams are in 1 mole of chromium? So what I like to do up top here is I take and I put 1 mole of Cr, and then I go ahead and I find chromium on the periodic table, and I look for the atomic mass, the average atomic mass on the periodic table. So I can see here that it is 51.9961. Now we are always going to round to 2 decimal places, and it's kind of weird. If you round to 2 decimal places with chromium, what ends up happening is you get 52 grams, and I'm going to put 00 grams of chromium for every 1 mole. Well, now we can use that in our conversion factor that we have set up. So step 3 here, we set up the conversion factor of chromium. And remember, when we convert something, the diagonal units must cancel out. So because we have moles of chromium, diagonal to the bottom right here, there must be moles of chromium. Now on top, because we can go from moles to grams of chromium, just like we have here, we can put grams of chromium. Now all we do is to insert the numbers that we see in that conversion factor that we have found from the periodic table. So it says 1 mole. I'm going to put 1 next to mole, and then I'm going to put 52 next to the grams because that is what the conversion factor told us to do. And so now all I have to do is calculate this particular problem out. So I'm going to start out by typing 0.0450 moles times 52.00. So I press enter, 2.34, and I'm going to divide that by 1 because that's what's on bottom. And I still get 2.34. And so this means that in 0.0450 moles of chromium, there is exactly 2.34 grams of chromium. And we abbreviate that by putting CR. And that becomes our answer. So then we move on. We move on to a very similar type of scenario here. But this time, we are going to be given, or we're going to start with the mass in grams, and we're going to convert it to the number of moles of this particular element. Again, we're only dealing with one element, so we'll only be utilizing the periodic table from right here. But the first step is to write down the given number of grams of the element. Now, the key thing here is that it has to be in grams. So we have to have that unit in grams. And then the second step that we're going to do here is we're going to determine the molar mass of the element. And this is another way of saying find the atomic mass of that particular element. Now, the atomic mass can be found on the periodic table. The third step in this process is to set up the conversion factor. And then you need to calculate and show the correct unit in step number 4. Now, the correct unit in this case is going to be moles of that given element in the problem. All right, so let's try an example here utilizing these particular steps. We want to know how many moles of calcium there are in 525 grams of calcium. So the first thing that you can do is write down what numerical value is given in this particular problem. So we have 525 grams of calcium. So we start out by writing 525 grams and then calcium. In case you forgot, calcium's atomic symbol is Ca. So this is 525 grams of Ca. Now I'm going to go ahead, I'm going to set up the conversion factor here. And what I'm going to do is this. I am going to have 1 mole, and I always like to write this at the top, 1 mole of Ca equal to the atomic mass of Ca. So what I'm going to do, I'm going to look on the periodic table, I'm going to find calcium, and I see that it has an atomic mass of 40.078. Now, we round that to 2 decimals, so the atomic mass here becomes 40.08. And that is 40.08 grams of calcium. And so now we go down to the particular conversion factor, and we have to keep this in mind. Diagonal units cancel out. So because I have grams of Ca in the upper left, the diagonal unit here is grams of Ca. Now my conversion up here says I can go from grams to moles. So I put moles on top, and it's going to be the same substance, still calcium, Ca. And now what I do, again, the numbers next to each of these units in my conversion factor is going to be placed in our problem. So next to grams in the conversion factor is 40.08. So I put down 40.08, and then next to moles is the number 1. All right, so we go through this process here, and the last thing that we need to do is calculate. So what I'm going to put in my calculator, I'm going to put 525, so 525 times what's on top, which is 1, so times 1, you press enter. Now you divide it by what is on bottom, which in this case is just 40.08, so you hit divide by 40.08, and you hit enter. And so we have 13 with a bunch of decimal numbers after that. Now I'm going to round that to 3 decimal places because of my 525 grams. So if I round that, and I shouldn't have said 3 decimal places, 3 total digits. So if I round that to 3 total digits, that answer rounds to 13.1. And then we have to remember, the unit for this is moles of that substance. And it's the same thing that is located in the upper right-hand corner of my particular conversion. All right, so we've gone from moles to mass and now mass to moles. Now we can tie in what we did just a section ago and piece all of those things together. So this is a little bit more comprehensive steps, and so that's why I've given a page for these particular steps. So we'll shift over here to our next portion here, and that is converting the mass of an element to atoms of an element. Now again, this is only a single element, so only one of those elements on the periodic table at a time right now, but we can go all the way from mass to atoms. Now, the first thing that we need to do here is write down the given number of grams of that element given in the problem. Now, if it's not in grams, you need to get it to grams or convert it to grams. And so what we do in the second step of this particular type of conversion is we determine the molar mass of the element. And again, this is just the atomic mass of that element. Now remember, the atomic mass can be found on the periodic table. The third thing to do here is to set up the conversion factor. And then what you have to do is calculate to determine the moles of the given element. Now, right here we're only halfway, and so what we need to do here in step number 5 is we use the calculated number of moles and multiply that number by the number of atoms in 1 mole of any substance. So remember, 1 mole has 6.02 times 10 to the 23rd atoms in each element. And then in step 6 here, all you have to do is calculate to determine the number of atoms in the given element's mass. Now the final units here will be in atoms. Now, a very important thing here. There may, or you may think there's a way to simplify this. Well, there's not. And this is extremely important, there is no direct conversion from mass to atoms of an element. All right, so let's put these skills to the test here, and let's go through this particular process in an example here. So, in our example, we want to know how many atoms of gold are in a 25.0 gram sample of pure gold. So let's start out and let's make this easy on ourselves. And all we need to do is write down the number in the unit of the given substance. So we have right now 25.0 grams of gold. Now, in case you don't know what the symbol for gold is, it is a U. So we have 25.0 grams of gold, and we first must go from grams of gold to moles. So our first thing that we're going to have up here is this: 1 mole of gold, AU, is going to be equal to some number of grams. That number of grams can be found on the periodic table. So we look up gold and we have the value here. And we're going to round to 2 decimal places. So this rounds to 196.97 grams for every 1 mole. So we have 196.97 grams of AU. We get back down here to the conversion factor. So now, remember, diagonal units must cancel out. So because we have grams of AU here, in the bottom right corner, we have to have grams of AU. Now we first have to go to moles of AU. So up top here, there is moles of AU. So I'm going to plug the numbers in associated with these units. And so 1 is associated with moles. And then grams here has 196.97. And that unit gets tagged along right here. So we have 196.97. And we can do our first calculation. So what we're going to do here is I'm going to punch in my calculator 25 times 1. So I have 25.0 times 1, and then I'm going to divide it by this 196.97. So I divide it by 196.97. I press enter, and I get this big long decimal. Now I'm going to keep a few extra digits. So what I'm going to do here, I'm actually going to keep a total of 4 decimal places in this scenario. So what I'm going to have here is I'm going to have 0.1269. So I have 0.1269 moles of AU. Now, the key thing here is that you need to keep a few extra digits than what you have to start with. So it's always good to kind of keep this excess and what we call this intermediate calculation. Now, this stuff that we just calculated becomes our starting substance. So now we have 0.1269 moles of AU. And I'm going to set up my conversion factor. And so in this case, I'm trying to get to atoms of AU. So up top here, I'm going to put 1 mole of AU is equal to Avogadros number, which, think back, Avogadros number is 6.02 times 10 to the 23rd atoms of gold. And I'm running out of room here, but that would be atoms of AU. So we get back down here to our conversion. Again, diagonal units must cancel out. So moles of AU is in the upper left. Diagonal from that needs to be moles of AU. Now up here it says, hey, I can go from moles to atoms, which is what I want to get to at the end. So I have atoms of AU on top, and then I just write down the numbers that are in front of these units here. So 1 is again associated with moles, and then our Avogadros number is associated with atoms, or 6.02 times 10 to the 23rd atoms of gold in every 1 mole. So what we're going to do here, we're going to type in, or I'm going to type in my calculator, 0.1269. So I have 0.1269, and I'm going to multiply it by Avogadros number. Now, scientific notation, when we do this, we're going to put a parenthesis. So 6.02 times 10, caret symbol, which stands for root, 23, close the parenthesis around Avogadros number, and we get this value here. Now I'm going to round to 3 total digits. So this is actually going to round to 7.64 times 10 to the 22nd atoms of AU. So again, the answer here is 7.64 times 10 to the 22nd atoms of AU. Now, we have to go through two conversions. So there's no shortcut. There's no way around doing two conversions. We have to go through both of these things to be able to go from grams, the mass of the substance, to atoms. All right, so we're going to do the reverse process here. So we're going to go over the steps, very similar type of steps, but we're doing the reverse process that we just went over. So again, we're going to go over this, the reverse process here, and this time we're going from atoms of an element to the mass of a single element. So the first step here is to just simply write down the number of atoms that are given to you. Now remember, the element symbol needs to be with this. Then what we need to do is we need to divide the number of atoms that is given by the number of atoms in 1 mole of a substance. So remember, 1 mole contains 6.02 times 10 to the 23rd atoms. The third step in this whole process is to calculate to determine the moles of the elements. Now the units in this case, in this intermediate calculation, should be in moles of a given substance. Now the fourth step here is to determine the molar mass of the element. And this is simply the atomic mass of the element that is given or listed in the problem. Now, this atomic mass can be found on the periodic table. The fifth step in this whole process is multiply the number of moles calculated by the number of molar mass of that particular element. And then what you need to do is just calculate and show the correct units, which will be in grams of that particular element. Now it's important to remember that there is no direct conversion from atoms to mass. You have to go through all of these steps to be able to do this. All right, so let's go ahead and put these steps to the test in our particular problem. So in our example problem here, it says a party balloon contains 5.50 times 10 to the 22nd atoms of helium gas. We want to know what is the mass in grams of the helium in the balloon. So the first thing that we do here is we write down our numerical value that's given. So we are given 5.50 atoms of helium. Now, in case you forgot, the symbol for helium is He. Now, we need to set up the conversion factor. And it says the first thing is that we need to go from atoms to moles. So remember, in 1 mole of helium atoms, there is 6.02 times 10 to the 23rd atoms of helium. So we'll use that here in just a second, but we cross diagonal here, and that means cancel units. So atoms of He need to go on bottom. And then we have to go to moles first. So moles of He are going to go on top. Now all we need to do here is we need to insert the numbers associated with each unit. So the number associated with atoms is Avogadros number 6.02 times 10 to the 23rd atoms. And then 1 is the number associated with moles. So all we're going to do here in our calculators is we're going to calculate this particular problem out. So I'm going to put 5.50. I'm going to multiply it by 1, press enter, and then I'm going to divide it by what's on bottom. So I'm going to divide it by parentheses because we're dealing with scientific notation, 6.02 times 10, caret symbol for root, and 23rd power root, press enter. Now I'm going to keep a few extra digits. So I'm actually going to keep 9.136 times 10 to the negative 24th. Whoop. And I made a mistake here. Made a mistake. No big deal. I could tell because my number was way off. All right, so forgot the power here. The power is located in the problem. I just forgot to read it. So it's times 10 to the 22nd atoms of He. So let's try this calculation again. So we're going to start out with 5.50 times 10 to the 22nd. So we get 5.50 times 10 to the 22nd, and we multiply that by 1. So we multiply it by 1. Now we divide by Avogadros number, which again, set of parentheses, 6.02 times 10 to the 23rd power. All right, so that looks a lot better here. Again, I'm going to keep 0.09136, and this is moles of He. So I have 0.09136 moles of He. Now, I use this 0.09136 moles as my starting business for what I'll have next. So I have 0.09136 moles of He, and I set up another conversion factor. Now, I go back to the table here, and I need to think, okay, 1 mole, and I'm going to write this above, 1 mole of He equals, well, how many grams? Well, we turn to our handy-dandy periodic table, and we find that atomic mass. And we're only rounding to 2 decimal places. So 2 decimal places for that average atomic mass of helium is 4.00. And that is going to be 4.00 grams of He. Now, we go back to the conversion factor. We need to cancel out diagonal, so that means the units down here need to be moles of He. And on top, we can go to grams of He in this case. And so we have this. Now to put our values, we just look to what we found. In every 1 mole, there is 4.00 grams of He. So to find our answer, what we're going to do is in the calculators, I'm going to put 0.09136, and I'm going to multiply it by 4.00. Then I'm going to divide it by 1. So I'm going to round my answer to 3 total digits. So I have 0.0365. So this is 0.0365 grams of He. And that becomes our final answer. So again, remember scientific notation, like I forgot there, that is going to be crucial to this whole scenario or these types of problems. Now, our final thing is this. This is just a method to show you the problem that we did earlier can be consolidated into one type of calculation. So this won't take very long because it's a problem we already did, but what I want to show you is this. We can take those multiple step conversions, which is what we just did, and you saw it was kind of time consuming because you had to stop, write down that intermediate calculation, make sure you rounded. But what we could do is we could actually do the conversion all at once. So in this, or what we have going on here, is that for atoms to mass and mass to atoms conversions, they've been done in separate steps. However, it is possible to make the same conversion in a single calculation. All right, so again, we've done multiple calculations for these multi-step problems, but what we can do is we can put this all together. So we've already done this problem, so we know the answer, but just to remind you here that in 1 mole of AU, there was 196.97 grams of AU. And then in 1 mole of AU, there was also 6.02 times 10 to the 23rd atoms of AU. Now, what I'm going to do here is I'm going to set this up in a very long, lengthy conversion. So I'm going to start out with what's given, 25.0 grams of AU, and I'm first going to convert my grams of AU to moles. So again, diagonal units have to cancel, so we're left with grams of AU needs to be on bottom, and we got to go to moles of AU first. That's a very key step. But our gram to mole ratio, we had it as 1 and then 196.97 moles. Whoop, made a mistake here. Not a big deal. It's always good to double check this. I said 1 mole and I wrote it in the wrong spot. So it's 1 mole and then 196.97 grams. So again, 1 mole to 196.97 grams. All right, so at this point, we calculated it last time. But what we can do is this. I don't want to stop there. I want to keep going. And now I'm going to cancel out moles of AU on the bottom. Again, diagonal units still have to cancel. And we want to end up with atoms of AU on top. Now, for every 1 mole, there is 6.02 times 10 to the 23rd atoms. So again, 6.02 times 10 to the 23rd atoms. So what we can do here is this. We're going to make one single conversion. So I'm going to take 25 times 1 times 6.02 times 10 to the 23rd. I'm going to press enter. I'm going to divide it by everything multiplied on bottom. And the key thing here is going to be parentheses throughout this entire process. So I'm going to, in my calculator, take 25 times 1 times, and this is key for parentheses, 6.02 times 10 to the 23rd. I'm going to press enter. Now, this is one calculation. I need to divide it by everything multiplied on bottom. So what I'm going to do is on bottom, I'm going to open up a set of parentheses. That is really key. And I'm going to type in 196.97 times 1. And I'm going to close my parenthesis here and press enter. And looky there, I get 7.64 times 10 to the 22nd atoms of AU. So I actually get the same answer, but you can see there that I did one single calculation of our conversion here. And again, this would be atoms of AU. I get the same exact answer. I just avoid writing it down again or writing that intermediate calculation, and I can get straight to the point. I made another mistake here. That's 7.64 times 10 to the 22nd atoms. All right, so it's 7.64 times 10 to the 22nd atoms of AU. Again, always check that scientific notation. Obviously, I had trouble here on the last couple problems, but always check that. And we have completed section 11.2. So there's a lot of calculations. I hope you have learned a lot. Just make sure you take your time. You set up the conversions correctly. Make sure the diagonal units are canceling out. And I hope you have enjoyed this video. And as always, subscribe.